Hello guys, welcome to OKONKOW Academy. So we are beginning the probability and statistics course, and for this we will be treating the probability aspect first. If you are new to this channel, please subscribe for us and continue sharing our videos to support us. Make sure you click on the like button and also put in all the questions that you have in our comment sections. So for the probability, we are to start with set theory, because this is the basics behind this course. I'll explain every single concept under this because I know some of us have forgotten. So with set theory, we are to know what sample species are. So what a sample species and what an event is to begin with. So when I say sample space, what I mean is it is the set of all possible outcomes of an experiment. So let's say we are to toss a coin. So for example, a 50 pesos coin. So we know a 50 pesos coin has the part with the woman. So we name that head, and the part with the coat of arms. So we name that part tail, right? So when we toss this coin, there are only two options. It's either it falls on the head with the woman or the tail with the coat of arm, right? So that makes it sample space, either head or tail. So because that's the only set of possible outcomes, right? Now let's take a coin. Sorry, let's take a die, right? So you know a die is like a cube, right? And it has 6 numbers from 1 to 6, right? So when we toss a die, it will either fall on either of these numbers, right? It can we can never get like 7 or 0 on a die. So that means that the sample space of a die is from 1 to 6. So 1, 2, 3, 4, 5, 6. I hope you understand. Now, what is an event? An event is a subset of a sample space. What do I mean by that? So an event is basically an occurrence in the sample space, a defined occurrence in the sample space. So, for example, with the tossing of a die, we can say that, oh, sorry, I said tossing of a die, maybe flipping of a die, I don't know how to, yes, tossing of a die. So, with the tossing of a die, we can say that and give us the outcome, or what will be the event when we want an outcome which is divisible by 2, right? So with that, let's name that event A. So with that, we can get the answer to be 2, 4, and 6. So this is what an event is. An event is an occurrence under the sample space. So you can see the outcome should not be maybe greater than 5 for a tossing of a die, right? So with that one, to let me name that one A. That one too can be 1, 2, 3, 4, or 1, 2, because they said the event should not be greater than what, 5. Yes, that's what an event is. But sometimes the experiment has a lot of information in it that we cannot easily write the sample space. So we use a concept called the tree diagram. It is a very, very easy concept. So we are going to practice what it is, right? So let's use this example to practice what the tree diagram is, right? So this question goes like this. An experiment consists of flipping a coin and then flipping it a second time if head occurs. If a tail occurs on the first flip, then a die is tossed. Now let's break it down. So the first thing we do in the experiment is what? Flipping a coin. So with a coin, what are the outcomes of a coin? A coin either gives a head or a tail. That is what the first thing of the experiment is telling us to do. So we flip a coin, and it's saying that when the first flip is head, which in this case is this, so when it is head, we flip a coin the second time. So when we flip a coin the second time, when it is head, so you draw your tree diagram on the head. That one too gives either head or tail, right? But when the first flip is tail, we flip or we toss a die, right? So we toss a die. So a die has 6 outcomes, either 1, 2, 3, 4, 5, or 6. So a die has 6 outcomes. So we are going to write what the sample space is. This is easy. So for you to write the sample space, you trace on the lines. So first, we can either get head and head. So head and head. Or head and tail. Or tail and 1. So tail 1. Or tail 2. Or tail 3. Or tail 4. Or tail 5. Or tail 6. So this is the sample space of the experiments that we did, right? Okay. Now moving on, we would be defining some set notations because that is what set theory is. So we'll be defining some set notations, and this is going to be used throughout this course, so please take your time to understand it. You can replay the video if you did not get it, but I'll take my time for you to get it. So first, you need to know what union is. Also, you would need to know what intersection is. Intersection. You also need to know what a complement is. Complement. Now, let's say we have a sample space of, let's say, a die, right? So then we have some events. Let's say A. So A is the even numbers of the toss, the toss of the die, and B, event B is the odd numbers of the toss of the die. And let's say an event C is numbers that are less than 5. Okay. So with that, let's move on to what the definition is. So the set notation to represent what union is this. So to represent what, sorry. So the set notations to represent what union is this. So this is union, right? So union of two events is basically the combinations of both of the events, right? It's a combination of both of the events. So if I'm to find the union of A and B, right, it's going to be combination of these two events. So now I'll combine them. So I'm going to get 1, 2, 3, 4, 5, 6, right? I forgot. Now, if S is the sample space, the elements in the sample space are called sample points, or simply elements or members of the sample space, anyhow you call it. So if I say union of A and B is the combination of all the elements in this event, right? Also, let's move on to intersection. So intersection is represented by this. So if I'm asked to do an intersection of A and C, or A and B, so what I'm to do is to find the elements or the sample points, let's say elements in A and C that are similar. So which elements are in A that are also in C? That is what intersection means. So with this, the elements that are similar are 2 and 2 and 4 and 4, right? So 2 and 4. That is what the intersection means. Now let's move on to complements. Complements. So complements. So with complement, it is represented by this sign. So if I'm asked to find the complement of A, the complement of an event are elements that are in the sample space that are not in the events, or occurrences that did not occur in the event that we are considering. So with the complement of A, it is just elements that are in this sample space that are not in A. So when we look at this, you can see 2, 4, and 6 in A. So we are going to write all the elements that apart from 2, 4, and 6 in the sample space. So this will be 1, 3, and what? And yes, and 5. So this is the complement of A. So please put the complement of B in the comment section. So what will be the complement of B and what will be the complement of C? I will check it, so please put it in. Okay, so now let's move on to Venn diagram illustration. Then when we are done, we solve a question, then we close for set notations. Now, Venn diagram illustrations. I'm going to use the notations that I just taught to explain this. We did Venn diagram in high school, right? And this is a three sets or three Venn diagram, right? So you are going to define the various regions, right? So this Venn diagram has a sample space S and 3 events A, B, C, right? So we will need to find what A intersection B, the region of A intersection B, the region of A intersection B intersection C, the region of A intersection C, the region of A prime intersection B. We will do all that. We will do all that. Now, let's find what the region A intersection B is, right? So the region A intersection B, when I say A intersection B, there are elements that are found in A and also in B, right? So elements that are found in A and in B are what? So A intersection B is this, right? A intersection B is this. So it is region 1 and region what? 2, right? So it is region 1 and region 2. Now, let's move on to A intersection C. A intersection C. So this is the diagram A, and this is diagram C. So A intersection C. This is very important, so please follow. A intersection C is this portion. Sorry. A intersection C is this portion. So that one too has 1 and what? 4. Now let's go to B intersection C. B intersection C. Now B intersection C. We know that this is B, right? This is the circle for B and this is the circle for C. So where B and C crosses is B intersection what? C. So that one too is this portion. So that one too is region 1 and 3. Follow as I do it so that you can really understand. Now let's move on to A. Now this is A, right? This is A. I'm going back to A because I know what I'm going to do, because when we are done, we will be doing what A prime is. Okay. Then B is also this circle and C is this circle, right? Now let's do A prime. A prime. A prime. So A prime is basically everything apart from A. Everything apart from A. That is A prime, right? So A prime is going to be this regions. A prime is going to be this region. So this is A. I'm going to circle A. I'm going to circle A, right? So everything that falls in A is not part of A prime. So A prime is going to be region 6, region 3, and region 5. So region 6, region 3, and region 5 is A prime. I hope we are all getting it. Now let's move on into B prime. So this is B. This is B. So anything that falls in B is not part of B prime, right? So region 7, region 4, region 5 is B prime. Now I would want you to do C prime. So tell me what C prime is for Venn diagram illustration. So please add that this is for Venn diagram illustration because I've already given you a particular C prime up there. That one was for the set calculations. Okay, so now we move on into, I'm going to erase all this. So you should take your notes before. I'm going to erase all this. So now let's move on into A intersection B intersection C. Right. So that one, A intersection B intersection C, it is where all the three circles cross. So when we look at it, it is this portion. So that is region 1. So region 1. Right. Yes. Now let's move on into A intersection B prime. A intersection what? B prime. So with that, I'm going to leave that to you to do. Also do A intersection C prime. So I've already told you that C prime, right, is everything apart from C. So let's do B prime so that you can do A intersection C prime. So B prime, right? B prime is going to be this region 7, 4, and 5. I hope you get that because B is this. This is B. So if I want B prime, it is everything that is not in B. So 7, 4, and 5, right? Yes. So A intersection B prime will be what is in A and is also in what? B prime, right? So A has 7 and also 4 because this is A. I'm using a different pen to mark what A is, right? So A has 7 and also 4, and we know that this B prime is what is in region 7, 4, and 5, and A has 7, 4, 1, and 2. So A intersection B prime is going to have what? Region 4 and region 7. So use this same idea to do for A intersection C prime and tell me the answer in the comment section. Thank you for watching this video to the end. Do well to like, comment, and subscribe. I would be solving this question with you guys in the next video. So I'll be solving this question with you guys in the next video before I close.